Okay, so we're going to continue with inequalities, but now we're going to add absolute values. So before we look at absolute value inequalities, let's kind of review what an absolute value is. So the absolute value of a number is its distance from zero. Distance is always a positive number, okay? So if you're looking at the number -4 or +4, their absolute value, their distance from zero, both of them are 4 units, okay? So to indicate that you're looking for the absolute value of a number, we use these little hash marks. So if I'm looking for the absolute value of -4, you put these little hash marks around it, and that would be 4. So -4 is 4 units from zero. Same thing for +4. +4 is 4 units for zero. But anyways, that's the notation we use for that. So what we're going to do is we're going to solve some equations that deal with absolute values. And so here are the steps for doing that. So isolate the absolute value. That is, write the equation in this form. The absolute value of your unknown is equal to a, where a needs to be some number. Okay. If a is less than 0, there's no solution. So let's look at an example of that. So let's say I want to figure out the absolute value of some value. We'll call it x. And let's say that it's equal to, whatever, -5. Okay, well, that's not possible because absolute value is distance from 0. Distance is always positive. So by definition, that's impossible for my absolute value to be negative. Okay, so there doesn't exist an absolute value that would come back as a negative value. Okay, so otherwise, if your equation, the absolute value is equal to a positive value or 0, it could be equal to 0, that's okay. You'll rewrite the equation where the value inside the absolute value is equal to a or it's equal to -a. So we're going to have actually 2 possible solutions for a lot of these. Okay, so then go ahead and solve the indicated equation and then check your answer. And so I have an example right here. So 2w minus 3, the absolute value of that, is equal to 5. So you want to look at it as being equal to 5, or it could be equal to -5. Okay, because this value inside here could be either 5 or -5, because the absolute value, the distance between 5 and 0 and -5 and 0 are both 5. So you set them equal to each scenario. So you set it equal to 5 and solve, set it equal to -5, do your algebra and solve. And then if you plug them in, you'll see they both work. If you plug in a 4, you'll get 2 times 4 is 8. 8 minus 3 is 5. The absolute value of 5 is 5. And then if you plug in the -1, 2 times -1 is -2. -2 take away 3 is -5. Well, the absolute value of -5 is also 5. That distance from 0 is also 5 units away. Okay, so we're going to start with some pretty easy ones, and then we might get one that looks pretty similar to our example up here. Okay, so on this first one right here, the absolute value of p is equal to 7. So what we're supposed to do here is you just look at p being equal to 7, or p could be -7. So either one of those could work. And so whenever you do on your homework, you're going to have the solution set again. So you just put in 7 and -7, just like that inside the set. So if you plug in either one of those, it will come back true. Okay, number 2 is a trick question. Okay, we already kind of talked about this right here. So what's going on is I have an absolute value equal to -7. That's impossible. So that one's going to be no solution. Okay, on your homework, it might give you the option for no solution, or it might have this symbol right here, and that's the same thing as no solution. Number 3, the absolute value of x is equal to 0. So what number is 0 units from 0? Well, that would be 0. So this is the one instance where you only have one solution. So we only have one solution for number 3. Okay, now we'll look at 12. So we have the absolute value of y, take away 3, is equal to 12. So this distance needs to be 12 units away from 0. So y minus 3 could either be 12 or y minus 3 could be negative 12, because either one of those, when you take the absolute value, it would be 12. So now we'll go ahead and solve this. So let's see, we'll add 3. So on this one, we get y equals 15. And on the other one, we get y equals negative 9. And once again, you can plug them in and see that what happens is the value in the hash marks either become 12 or they become negative 12. And that distance, both of those distances are 12 units from 0. Okay, one more example like this, and then we're going to throw in the inequalities with these. All right, so let's see. 2x minus 3 is either equal to 4 or it needs to be equal to negative 4. Okay, so on this first one, let's see, we'll add 3 to both sides. So we'll have 2x equals 7. And then we'll divide by 2, divide by 2. So we get x equals 7 over 2. All right, and then on this other one, let's see, we'll add 3, add 3. That cancels out. 2x equals, clean that up a little bit, sorry. 2x will equal negative 1. And then we'll go ahead and divide by 2. And so x equals negative 1/2. Okay, so that was kind of hopefully a little refresher on absolute values. So we're going to throw in inequalities, and they're going to be kind of weird at first, but once you play around with them, they're not too bad, but they are a little tricky to kind of wrap your head around. So we'll look at the definition, and then we'll actually look at an example, and I think that will help. So right here, it says let a be greater than 0. Basically, let a be a positive number, okay? So you have your absolute value, and the absolute value is less than some positive number, okay? So a needs to be positive. Then, if you have this statement right here, the absolute value of x is less than a, then that value inside the absolute value needs to be squeezed between the opposite. It needs to be squeezed between negative a and positive a. And then here's a visual of the number line right here. Okay? All right, so looking at the definition probably doesn't help you too much. You kind of need to actually see it in action. So if we look at number 12, you need to really think about what's going on. We're looking for numbers, okay, the absolute value of t. We're looking for numbers that are less than or equal to 3 units away from 0. So if you were to look at a number line, okay, here's where 0's at, right? So whatever numbers I pick, they need to be less than or equal to 3 units away from 0. So you could go 1, 2, 3 this way. You could go all the way up to 3. That's 3 units away from 0. Or you could go negative 1, negative 2, negative 3. That is still 3 units away from 0. So your interval is going to be from negative 3 to positive 3. Okay, so that's kind of the visual. And so, but you're going to want to follow this definition up here, because they're not always going to be as clear as this first one, number 12, okay? So the definition, what you're supposed to do is take the value inside the absolute value and squeeze it between 3, and the opposite, negative 3. And whatever inequality symbol you have here, you just pop it on the other side, okay? So if it was a less than, then you pop a less than over here. If it's less than or equal to, then you put the less than or equal to over here. Now, if you're dealing with a greater than symbol, that's going to be a different rule, okay? So we'll look at that one in a minute. But for right now, if you have the less than, you're going to squeeze it. If it's greater than, we're going to do something different. So just hold off on that one. Okay, so coming down here, I already did my number line. You can kind of see that I kind of made a generic one. And then your interval notation would be from negative 3 to positive 3. And so any of those values you plug in, that absolute value, that distance is less than or equal to 3 units from 0 right there. Okay, so make sure You understand number 12, okay? Because if you're a little fuzzy on that, you might want to rewind and kind of go over it again, because as we get on to like number 14 and 15, you're going to have to rely more on the formula that we kind of use from up above. 13 is just kind of a trick question because it's asking us what absolute value is less than or equal to -3. So they're asking you what value from 0 is less than or equal to -3 units. And so kind of like what we saw on the previous page, that's an impossible question, or not impossible, but basically has no solution. So this one's going to be no solution again, because you're looking for a number smaller than -3, like -4, -5, and distance from 0 is always positive, so we can't come up with those numbers. So no solution on that one. Okay, so with this in mind right here, we're going to move on to the ones that are a little bit more challenging, to where it's a little bit harder to kind of visualize what's taking place. You kind of more need to rely on this up here, this rule. Okay, so looking at 14. All right, so see, we have the less than or equal to, so you should know that you're going to squeeze it. So you want to rely on that. You want this expression right here, x minus 1, it needs to be less than or equal to 2 units away from 0. So you want to be less than or equal to 2 units from 0. But you have to be careful. So let's look at this on the number line. Let's see, I'll put this down here. Here's 0, here's 2. So you want this expression, its distance, to be less than or equal to 2 units away from 0. So you don't want to go above 2, which makes sense. So you start shading this way, but you have to be careful, because there's 1, there's 2, there's 3. If you go past, I'm sorry, negative, right? -1, -2, -3. If you go past -2, all of a sudden that distance is greater than 2, and you want to be less than or equal to 2 units away from 0. So on the other hand, we're going to say this expression needs to be greater than or equal to -2. So this is our compound inequality. So on one hand, I need to stay larger than or equal to -2, because I don't want to go past this part right here. If I go past that, then my distance exceeds 2. And then on the other hand, I have to stay smaller than 2, because if I go above 2, then once again, I exceed a distance of 2. Okay? It's one of those things that once it really kind of clicks in place for you, it's not going to be a problem, but it takes a little bit of time and experience. Okay, so I need to go ahead and solve this, though, okay, because this number line actually is not correct. That's not what my answer is right there, because I have a little bit of algebra to do in the middle, okay? So now I need to go ahead and clean this up. So we'll go ahead and add 1 everywhere. And so now we're going to get, let's see, -1 is less than or equal to x, which is then less than or equal to 3. So that's my actual solution set right there, is from -1 to 3. And that's my interval right there. And so if you want, you could play around with plugging in some numbers, and you'll see that it would work. Because if you plug in 3, 3 minus 1 is 2. The absolute value of 2 is 2. That's okay. And then if you plug in a -1, you can see -1 minus 1 is -2. That would be the absolute value is 2 also. 2 is less than or equal to 2. And then if you plug in anything in between, you're going to get a value that's less than 2. You'll get a value that's less than 2 if you plug in anything in between. Okay, let's take a look at 15. So once again, this is, see, it starts to get complicated with what's going on in the middle. And so you just need to know that what's inside your absolute values right here needs to be between 8 and -8, okay? Because you want to be less than 8, but you don't want to go beyond -8. So once again, here's your absolute value or whatever, and here's 8, and here's -8. So you're trying to squeeze whatever's inside here between that. So we're going to take 2x minus 6, it needs to be less than 8, but it also needs to be greater than -8. Because if I go beyond -8, I'm too far away. So now we'll go ahead and solve this. So I'm going to add 6 to all 3 parts right here. That cancels out. So let's see. That'll give me a -2 is less than 2x, which is then less than 14. And then we'll go ahead and divide everything by 2. So let's see, -1 is less than x, which is then less than 7. So our solution set our values between 1 and 7, or I'm sorry, -1 and 7, but not including those values. So we have to use the parentheses to indicate that those points are not actually included. Okay, so that's you'll notice that all these were less than, or equal to, right? So that was our first set that we were looking at. We were following this rule up here. Now we're going to look at whether we're dealing with greater than, because it is going to be a different way to approach it. Okay, so here we are. So right here it says, let A be greater than 0. So once again, they're saying let that A value be greater than 0. And if it's not, then we're dealing with some type of special case. Then this is the result. So if you have the absolute value needs to be at least, however many units from 0, then x is greater than A, or x is less than -A. Okay, and then here's a visual of it. So once again, it'll be a little bit easier once we look at it, an example and see this in action. Okay, so what we're saying here is we want all the numbers that their distance is more than 6 units from 0. So once again, let's look at the number line right here. Here's 0. So here is 6. Here is -6. You're looking for all numbers that are more than 6 units away from 0, like 7, 8, and so on, or -7, -8, and so on that direction. So you're shading away from 0 this time, and we're going to have parentheses because of the inequality symbol. We don't have the equals to part with the inequality symbol. And so that's the number line of this, okay? And then you can figure out the interval notation. I'll help you with that in just a second. So following the rule up here, this would be x is greater than 6 or x is less than -6. So you have to reverse it and change the sign. But that's exactly what this is right there. And like I said, hopefully the number line visualizing it makes it a little bit easier to understand. But as the problems get more complicated, once again, you're going to have to more or less rely on the rule to help you here. Okay? So the way you're going to write your interval here, we're going to use we want to go from left to right. So the left interval is from -infinity to -6, okay? And then you should have a tool on your toolbar when you're doing your homework, and it should just look like a capital U, okay? And it stands for union. So you're basically, you unite the two sets together as your solution set. So union, okay, union, and then from 6 to infinity. So like I said, when you're doing your homework in my math lab, there should be a toolbar at the bottom, and you can use that symbol right there that looks like a capital U. Okay, 17 is more or less kind of a trick question. So far, most of the time, we've been getting no solution, okay? This case is actually going to be a little different. So right here it says the absolute value of x is greater than -6. So you're looking for what numbers are greater than -6 from 0. And so if you look on a number line, here's 0, right? What numbers are larger than -6? Their distance, not the actual numbers, their distance. And that would be all numbers. 1's greater than -6, so is 2, 3, 4, 5, 6, 7, 8. So are the negative ones, though, because when you take the absolute value, that distance from 0 is positive also. So basically, all numbers, their distance is greater than -6 from 0. Okay, so think about that. All numbers, if you take their absolute value, their distance from 0, they're all going to be greater than -6. Okay, so for example, even if I had -7 right here, If I take the absolute value of -7, it's +7. +7 is greater than -6. That is true. Okay? You could try another number here. You could try, whatever. We could try 10. So the absolute value of 10 is 10. 10 is greater than -6. Yeah, 10 is larger than -6. If you take any number here, take the absolute value, it is going to be greater than -6. You could try -2, -3, any number you pick, take the absolute value. Positive numbers are always going to be greater than -6. So the way we're going to write our final answer is, what we want to do here is from -infinity to +infinity. It's all real numbers. So from negative to +infinity, and if they shade the number line, they're just gonna, you'll see number line solid in both directions like that. Okay, but the ones that we're gonna do, the last two we're gonna look at are gonna be more like number 16, except that hopefully 16, when we kind of walked through it, it kind of made sense, especially with the number line kind of helping out here. But kind of like the previous problems, they're going to get a little bit more complicated, and so you're going to want to rely on the rule that we established up here. So if the absolute value of some expression is greater than a, then you need to look at it as being greater than a or being less than the opposite. Okay, so moving on down here for our last couple. Okay, so if we look at 18 right here, so yeah, we have the greater than or equal to 4. So we want to be, so if you look at this, here's 0, here's 4, here's -4. You want to be at least that far away. So we're shading out from the 4s and -4, okay? The only thing is there's an expression in here, though, so there's a little bit more going on. So you're going to have to actually do a little algebra. So this is not quite what our number line is going to look like at the end. So we're going to take x minus 1. It needs to be greater than 4, or x minus 1, x minus 1 can be less than or equal to -4. Okay, so on the first one, let's see, we'll add 1. We'll get x is greater than or equal to 5. Or on this other one, we'll add 1. And we're going to get x is less than or equal to -3. And those are our answers, but now we need to put it onto a number line and shade, and then put our interval notation. So x is greater than or equal to 5, or x is less than or equal to -3. So I'm going to start with the x is less than or equal to -3. So this is just a little generic graph. It doesn't need to be, real pretty or anything like that. So here's where -3 is. X is less than or equal to. So all these numbers, if I plugged them into the original, they would work. And then the other one is greater than or equal to 5. So that would be this part of it right there. And that looks good to me. So the interval notation here, you always want to go from smallest to largest, -infinity to -3, and then union 5 to infinity. And there you go. Okay, so like I said, make sure you get a good understanding of the very first example, the very basic one, number 16. But then after that, you really do kind of want to rely on this. And as time goes by, you'll get, a better understanding of it. But make sure you wrap your head around 16. But then on these other ones, for the most part, rely on the rule to help you out here. Okay, so our last example here. So this expression needs to be greater than 7 units. So 3x minus 8 needs to be greater than 7. Okay, or because you want that distance from 0 to be greater than 7, or 3x minus 8 could be less than -7, and that would cause the distance of that expression to be more than 7 units away from 0. So hopefully that's starting to make a little bit more sense. So now we need to solve each one of these. So let's see, we'll add 8. So 3x is greater than, let's see, 15. Or, let's see, we'll add 8 here. 3x is less than 1. and then we'll divide by 3. So I get x is greater than 5, or, let's see over here, we'll divide by 3. X is less than 1/3. All right, so we'll come down to our number line. And so x, oops, jumps on me. X is less than 1/3, so I got to use a parentheses just to kind of estimate where 1/3 is. And then we'll shade. And then x is greater than 5. Let's put a 5 right here, and then shade. And there you go. And then now you just have to write it as interval notation. So negative infinity to 1/3, union from 5 to infinity. Okay. All right. So yeah, these sometimes can take a little time to kind of wrap your head around. So just kind of practice them, and don't overthink some of this stuff. I think it is a good idea to try to to understand the simple ones, but then when you get to these, just kind of rely on the rule to kind of get you through it. And as time goes on, like I said, you'll just continue to get a better understanding of it.